So you have to do Cal 3, 15, 7, page 1120, number 7. Here's an integral with a specified region that you want to integrate over. We roughly graphed it here, and we can see that this would be inconvenient. Why is that, Eric?
You have to integrate it in 3 different sections. You'd have to find intersection points, and it's a big mess.
Right. Makes sense? So, the book gives us an idea to use the transformation given with these equations. You will see why in a few minutes. This is a really nice transformation to use for this particular problem. Okay, so what we're doing now is we're taking the transformation as written and solving for x equals or y. And we multiplied the bottom equation by -3. I like this new beginning.
Yeah.
So, u minus 3b. So, Brian, what do you think we got here?
Yeah, for y.
Okay, here's 2 of them. Here's -12 of them.
Negative 10y.
Oh, that's what you're asking. Okay.
Yeah. And so then y is -110, u minus 3b.
And then you just keep taking y triple prime.
Oh wait,
and plug
we
it
want,
back in here.
we already got, yeah, that's right. We had u and b presented. Now we want x and y.
And then you just
That's just taking
set them equal to each other.
Go back to bed. Okay, this is good. This is real good. Y equals. Okay, so now to get x equals, we'll do the same thing, or a similar thing. Instead of getting rid of the x's, we'll get rid of the y's.
Yeah, y is equal to y, c equals y, b, whatever.
Yeah, you add the left side in.
All right, Eric, you just got to tell me what to do.
Multiply the top by -2.
X cubed or a.
Yeah, you're gonna have. Just have the
X cubed.
x squared.
-6 of them, plus 1 of them, -5 of them. Okay.
Don't you need another variable there?
So here
Because
are the same equations as the u equals v equals, only written solve for x and y. Here's the deal. We can trade this integral for another double integral, which has
Well, that's okay, because you got x cubed too, you can have like the whole factor alpha.
u and v as the variables by, first of all, trading the integrand for an appropriate integrand written with u's and v's. So 3x squared,
The book says different.
and since we're not going to integrate it, why don't we just play with this integral?
Squared and another one.
And why don't we just make it, just take the first term.
A
So
through
just do
b
that.
up there, trying to solve for all those, and we have a
We're not going to integrate it anyway, because you know how to do that.
problem.
So just to show you how to take your integrand and transform it into u and v, take your 3x squared, rewrite it in terms of u and v. So it's it's a 3 times this squared. See what I'm saying, Michael? So this would be we'll just make it 2/5 squared. Actually, let's just make it this. 2/5 u minus 1/5 v. Okay, that would be 3x squared. Do you remember in the old days when you had a u substitution to do because you couldn't evaluate your integral very conveniently? Something.
I remember having a double integral.
Oh, sorry, right, a single integral. Remember, you say u equals, and then you say du equals, so that you can transform not only the integrand, but also the dx into a du. Well, something similar has to be done with double integrals. And what you have to use is the two-dimensional equivalent of the derivative which is the Jacobian. So what goes right here, actually, is the absolute value of the Jacobian. The Jacobian is the determinant of this partial derivative matrix. Xu, xv, yu, so xu is,
I think you're
Anybody?
gonna need more room.
huh?
I think you're gonna need more room.
Yeah, I'll erase this. 2/5,
Yep.
xv,
Negative 1/5.
yu, and yv.
Negative or positive 3/10. That was easy.
They all are. I mean, we don't start off with.
Now we take the determinant of that. So that's gonna be. Just something. you
6
need a
over
calculator
50.
for that.
Minus,
Plus. Oh, good point. 3 minuses is a minus.
good.
You can't just say.
You know what you can do? I don't know if it'll help you, but what I always do is just change one of the signs. As you go to do the second cross, just change one of them.
Why?
Because it's the determinant is the top right, bottom, or top left, bottom right minus. And so you're going to have an additional negative when you're putting those together.
Yeah. So why can't you just do that?
Whatever you
Because
want.
not everybody has a memory such as yours, right?
No.
6 of them take away one of them is 5 of them, so 5/50th is 1/10. So the Jacobian is 1/10. And let me tell you something that I used to get confused on. Michael, this thing that you put in here is the actual absolute value of the Jacobian. So if this Jacobian had turned out to be negative, you just make it positive.
So you can have 3/10 times all that. If you were to put together your coefficient.
Uh-huh. One more thing, and then we've got the whole thing set up, the whole integral set up with using
Hey, when you have double integrals, can you pull out, like, you know, like you pull out a coefficient on a single integral? Can you do that? If you did that for a double integral, would you pull it in front of just a single integral? Like in
Sure, a
between
lot of
the two?
people do.
But you can't bring it out in front of both of
V's
them.
out. If you had a V term, you could even pull that V term out to the middle.
Yeah, because you're integrating du.
But I mean, if you had like that 3, you could have put that 3 in front of the double integral, in front of the
Either
very
way.
front.
Yeah, either way.
You can actually pull it out in the very front?
Well, yeah, because you would move it in front of the other integral, and then you have a constant in front of an
Oh, yeah,
integral,
yeah, you could.
and you move it to the next
But you
integral.
couldn't do that with a V.
No.
The V could go here.
Okay.
Brandon, what do you think?
Off subject, the test, the retest. For number 5, you have in parentheses, you'll have to use D's. Do you want us to use D's, or can we solve it without using the D's?
How are you going to solve it without the D?
If I can.
How? How'd you do it? How would you do it?
Eigenvalues? I don't know.
It doesn't work for eigenvalues unless I'm mistaken.
Well, there's another little trick, but you can
Oh.
definitely solve it.
You'll have to show me the trick. Yeah, I'd be curious to know the trick. Yeah, interesting.
So you're saying that I don't have to use D's, as long as I've solved the differential equation, I'm good, right?
No. What I should have made clear is, show me the trick, and I'll let you know if I think it's okay to use it. How about that? Isn't that fair? Show me the trick. Show me as soon as we're done with this. Okay. We need to put U limits and V limits on this integral, and then we'll be done with the transformation. Look at this. If we multiply everything by 2 and move this x term over here, we're going to see 3x plus 2y equals